Hi everybody, I am Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Now we can discuss the topic of types of molecular velocities. When we have different kinds of speeds in gaseous molecules, to study the different speeds, we should classify the different speeds. The first one is the most probable velocity. The second one is average velocity. The third one is root mean square velocity. The three types can be expressed as velocities or speeds. So we should be careful in knowing the meanings. In this case, this Cp within C square whole 1 by 2 are symbols. They may vary according to the books. They may vary. So these are all symbols. These are all not units. So they can be used with different symbols in different books. So let us know the meaning for all those things. So first thing is the most probable velocity. The velocity possessed by maximum number of molecules of a gas at a given temperature is called most probable velocity. So this is the first one, first type. Then the second type is the symbol within C, that is average velocity or mean velocity or average speed or mean speed. So from the word itself we can understand what is average velocity. It is the arithmetic mean of different velocities possessed by the molecules of the gas at a given temperature. So the velocity possessed, the average of the velocity or the speeds possessed by different molecule is called average velocity. So this can be explained in a simplified manner with the formula. So if there are 100 molecules and every molecule are possessing different speeds, and we have to C1 is the velocity of the first molecule, C2 is the velocity of the second molecule. Likewise, we have to add all the speeds of the molecule divided by the total number of molecules. Okay. Or if the 100 molecules, for example, if the 100 molecules, among the 100 molecules, 25 molecules are possessing a particular speed, then remaining among the remaining 50 molecules are possessing a particular speed, and another 20 molecules are possessing a different speed, and another 5 molecules are possessing a different speed. If that is the case, what should we do? We have to write the number of molecule, the 25 molecule, for 25 molecule, 25 into the speed possessed, into 50 into the speed possessed, plus 20 into the speed possessed, plus 5 into the speed possessed, divided by the total number of molecules. Likewise, we can calculate the speed of the molecules, gaseous molecule. So it is the average of different velocities possessed by the molecules of the gas at a given temperature. Likewise, we can calculate. And what is RMS velocity or root mean square velocity or root mean square speed? It is from the word again. Root means taking root or whole power 1 by 2. Mean means average. Square means we have to square up to the any value to the power 2. Okay, so all these things should be done to a particular particular gaseous molecules. So it is defined as the square root of the mean of the squares of different velocity. So three things should be taken into the point, as it is present there. Rm as root mean square, we have to take root, we have to take mean, we have to take square. That is what we have here given in the definition. Square root of the mean of and squares of three things should be taken into consideration. Okay, so this is the value, and for this we have to take the speeds first. We have to write the speeds, and we have to square up the value, and we have to add, and we have to divide it by the total number, and we have to take the root for the entire value. So mean, as we have taken average mean value, and we have to square, and we have to take root. So average, square and root, that is root mean square, RMS. Okay, in this case also, if a group of molecules are possessing a same speed, are traveling at a same speed, we have to write like this. The first group N1, the velocity possessed by the first group, and square of the product, plus the number of the second group, and velocity possessed by the second group, then square, then the overall root. So likewise we have to calculate. So it is defined as the square root of the mean of the squares of different speeds possessed by molecules of a gas at a given particular temperature. Likewise we can find the root mean square velocity. Next, these are the definitions and representations for different speeds or different velocities. Now, with what is the formula to find out the value, to find out average velocity, to find out root mean square velocity, to find out most probable velocity? Okay, so using Maxwell's equation. What is Maxwell's equation? We should know the Maxwell's equation. It is 4 pi into m divided by 2 pi kt whole power 3 by 2 into c square exponentials of minus mc square divided by 2k into dc. So we should know what are they. The c is velocities, and dc is the spherical shell of the thickness, and at a distance c. du, dv and dw are the shell has the volume 4 pi c square dc, and we have like that we have several values. So with that we can arrive at a equation which is arrived by Maxwell in the year 1860. Now we need not worry about that. So using the equation we have derived the mathematical expression to find out the most probable velocity, average velocity and root mean square velocity of gaseous molecules at a particular temperature. Okay, so what we have arrived at? We have arrived at these expressions. So Cp is equal to 2 kt by m whole power 1 by 2 is equal to 2 RT by m whole power 1 by 2. 1 by 2 can be mentioned like this, or we can put a root symbol. So here that is most probable velocity. This average velocity is equal to 8 kt divided by pi m whole power 1 by 2 is equal to 8 RT by pi m whole power 1 by 2. This is the formula used to find the average speed. Then root mean square velocity is equal to 3 kt by m whole power 1 by 2 is equal to 3 RT by m whole power 1 by 2. Okay, so this is the formula used to find out root mean square velocity of gaseous molecule. How can we memorize? Just to memorize, you can have just 3 means RMS. Likewise, we can relate the formula with the equation. Okay, then for other things we cannot have any other things. Okay, so and we have a relationship between the values of speeds, different speeds. The root mean square velocity is equal to average velocity is equal to most probable velocity. So for most probable velocity we have most probable 2r. Likewise we can relate some values. Okay, so what is the ratio of these speeds? The ratio of different speeds will be like this. RMS is, if RMS is 1, then that is equal to average 0.92 is 0.82 for most probable velocity. 1 is to 0.92 is to 0.82. This is the ratio for all these different speeds. Next, the graphical representation for the speed. Okay, so when we plot the values of number of molecules in the vertical axis and velocity on the horizontal axis, and we will get a curve like this, and this point will be most probable velocity, and mean velocity here will be getting a place between RMS and most probable velocity, and here we will be getting the RMS velocity. So this is just a graphical representation of Maxwell's velocity of molecules. Thank you.